Section 2.5 is titled Solving for a Variable. So in order to solve a formula for a given variable, the first thing you want to do is locate the variable you are solving for and underline it. Then you want to identify the different operations that are happening to this variable, and then use inverse operations to undo the identified operations from step 2 so that we can isolate the variable. We want to clear fractions, undo addition and subtraction, and then divide. So for our first example, we need to solve the following equation for r. And what we have here is d equals r times t. What you want to remember when you are trying to rearrange an equation to solve it for a different variable is it's really not any different than just solving an equation. But instead of using addition and subtraction of numbers, we're actually going to be using addition, subtraction, multiplication, and division of variables. So here we have d equals rt, and we are asked to solve the equation for r. So here's r. And what we need to figure out is what's happening to the r, because we need to get it by itself. And this one's fairly simple because the r is simply being multiplied by t. So we want to do the inverse operation of multiplication, which is division. So we want to divide both sides by t. What happens then on the right-hand side is the t's cancel, and we're just left with r. And on the right-hand side, we have d divided by t. So we solved the equation for r by isolating it. R equals d over t. Here, solve the following equation for m. See the variable m? Right now it has an n being subtracted from it. So what's the opposite of subtracting n? The opposite of that, or the inverse operation, would be adding n. So we need to add n to both sides. What happens on the left is that the n's cancel out, and we're just left with m equals, when we add n to 5, it's just 5 plus n. Since we don't know what n is, we can't actually add it to the 5, we just tack it on to the back. So we've solved the equation for m equals 5 plus n. Here's one that's a little more complicated. We want to solve this equation for c. So there's c. We see that it's being multiplied by a 9 over 5, and there's also a 32 being added to it. Well, one of the easiest things we can do is get rid of fractions. So if we multiply everything by 5, remember, everything on the left and everything on the right gets multiplied by 5. That gets rid of the fraction. So we have 5f equals 9c, because the 5's are going to cancel. And then in a calculator, you can do 32 times 5 to get 160. Again, we're trying to isolate the c, so we see it's being multiplied by a 9 now, and 160 is being added to it. Well, we always undo addition and subtraction first, so we want to subtract 160 to the other side. Now, what you need to pay attention to is that on the left-hand side, those are not like terms. We have 5f, think of f as just like a variable, and we're subtracting 160. So we have 5f minus 160 equals 9c. Still trying to isolate c or solve the equation for c, so we need to divide both sides by 9. On the right-hand side, those 9's will cancel. On the left-hand side, we actually can leave it just like it is. So our final answer, solving the equation for c equals 5f minus 160 all over 9. Okay, number 4 says solve the following equation for w. We have s equals w minus 10e, and it's all over m. So first we see that fraction, and we want to get rid of that m in the denominator. So what do? Hopefully you're saying multiply both sides by m, because that's going to cancel the fraction on the right. On the left, you're left with m times s, or s times m, either way, and it's going to equal w minus 10e. Again, we're solving for the w, so that's what we're trying to get by itself. Right now we just have the w with a 10e being subtracted from it, so we're going to add 10e to both sides. Just like solving an equation, we always use the inverse operations. Addition and subtraction are inverse, multiplication and division are inverse. So on the left, we have ms plus 10e. Those are not like terms. You can't say 11 mse or anything like that. Equals w. So we've solved the equation for w. Another example, if you'd like to pause the video here and try this one on your own, you're to solve the equation for x. So we see that x has a 3 being multiplied to it, and it has a z being subtracted from it. So we always want to take care of the inverse addition and subtraction first. That'll cancel on the right. So you have y minus 4 plus z, and it equals 3x. Now we divide both sides by 3. And we get that x equals y minus 4 plus z, and that's all over 3. And it's okay to leave it just like that because we do have the equation solved for x. The last example looks at the formula for the area of a triangle. So the formula for a triangle for the area is a equals 1/2 base times height, where b is the length of the base and h is the height. So solve for h. So here we have area equals 1/2 base times height. We want to solve for h. The easiest thing to do first is to get rid of the fraction, so we multiply the right side and the left side by 2. Notice this is all one term. It's all multiplication in between there, so that whole piece just gets multiplied by 2. You don't multiply the b by 2 and the h by 2. That's very different than if we had something like this. In this situation, you would multiply everything by 2. So take a look and make sure you recognize the difference. So on the left we get 2a, and on the right the 2 cancels with the 1/2, so you just have b times h. We're trying to solve for h. Right now it has a b being multiplied to it, so in order to undo multiplication we are going to divide by b. So we get h equals 2a all over b. In class, we'll work on worksheet 2.5, and the important thing to remember here is just that this is just an undoing or a rearranging of an equation.